Let's talk about light. Have you ever noticed that when you change a light bulb, sometimes the color of the light looks more bluish or more yellowish? This has to do with the emission spectra of the element of the bulb. The study of these photons, or emitted light, is called spectroscopy. But how does the element produce the light? Let's take a closer look at the atoms. A kid playing outside can represent our electron, her home the nucleus of the atom. Just like every kid has different rules about how far from home she can go, each element has set energy levels. And, just like some families have more kids, each element has different numbers of electrons. Let's say a photon is like a scooter. When a kid gets a scooter, they can go farther from home, just like how an electron that absorbs a photon jumps out an energy level. When the kid gets tired, she can head back home and leave the scooter for other kids to play with, like how an electron jumping down energy levels emits a photon for other atoms to absorb. These emitted photons determine the frequency of light, most easily seen as color. Driving along a road at night, you'll notice that the light from the street lamps is mostly yellowish. Streetlights use sodium vapor bulbs to produce light, and the most common photon emission from sodium falls in the yellow light section of the spectra. While some elements may have similar primary emissions, the same color happens most often or the brightest, there are no two elements with the same emission spectra. For example, barium and sodium both burn yellow, but barium burns a greenish yellow, sodium a more orange yellow. The knowledge of how elements burn helps us make more effective light bulbs, creative signs, and colorful fireworks. Spectroscopy isn't just useful on Earth, though. A group of women called the Harvard Computers used the emission spectra and temperature to classify stars. They began studying photographs of stars and their spectral emissions under Edward Pickering in the late 19th century. In 1896, Annie Jump Cannon joined the group of female astronomers recording data on the stars. Through their use of emission spectra, they classified stars into 7 categories that are still used today. Her work also helped Cecilia Payne come to the conclusion that stars were mostly hydrogen and helium, where most other scientists believed they had similar compositions to Earth. Thanks to spectroscopy, we have a better understanding of the universe and what's in it.